Hey, welcome back to West Virginia. Maybe. Anyways, it's time for joke of the day because you know it's the best part of the day. Now, today's joke is, what do you call someone with no body and no nose? Nobody knows. But you know what? We do know about polynomials. So let's take a look today about dividing a polynomial by a monomial. Now remember, nomial means term, so poly meaning many means that I've got many terms that are divided by one term because mono means one. So I'm going to take a whole bunch of terms and divide each of them by one single term. So if you're taking a polynomial and you're dividing it by a monomial, what you're going to do is divide each and every term of that polynomial by that monomial. So we're going to take a look at 4 examples, 2 here, and then we'll flip the board and get 2 more. And in this first example, notice that it says that I'm taking a binomial. Bi means 2, so I've got term here, term here. Terms are separated by addition and subtraction. So I've got one term right here, and then there's the subtraction separating out that second term. So I'm going to take this binomial and divide it by this single monomial. So what that indicates to me is I'm going to take that first term, the 24x to the 4th, I'm going to divide it by 8x. Then I'm going to take the next term, that negative 8x to the 3rd, and I'm going to divide it by 8x. So when I take a 24x to the 4th and divide it by 8x, this goes back to what we just learned about dividing our bases. Because remember, we said that this is a division problem, and I am going to divide the coefficients. And 24 divided by 8 definitely is a 3, no doubt about that. But when I do x to the 4th divided by x to the first, remember, when I divide those same bases, I'm going to keep the base because it's all about the base, But then what I'm going to do is subtract those exponents. And 4 minus 1 will give me 3. So that's how I get 3x to the 3rd. Then when I take a look at this one, recall that 8 divided by 8 is a 1. And now when I divide these bases, once again, when I divide same bases, I'm going to keep that base because it's all about the base, And I'm going to subtract those exponents. 3 minus 1 will give me a 2. So when I divide this, I get a 3x to the 3rd minus, and when I divide this, I get an x squared. Now remember, if you can combine up like terms, definitely do, but like terms have the same variables. Those variables are to the same power. They both have x's, but this is an x to the 3rd, this is an x to the 2nd. They are not like terms, so I cannot put them together. This is as good as that one gets. Now, let's take a look at the next example. Once again, terms are separated by addition and subtraction. So I have a term sitting right here. Here's the subtraction, which is the name tag on that second term. Here's the subtraction, that is the name tag on that last term. I have 3 terms in there. Recall that that means this is a trinomial. Tri means 3. So I'm going to take that first term, my 8x to the 6, y to the 3rd. I'm going to divide it by that monomial that's in that denominator, negative 4x to the 6, y squared. Then I'm going to take my next term, my minus 12x to the 8th, y squared, divide it by the monomial, negative 4x to the 6, y squared, and then take that last term, my negative 4x to the 14th, y to the 6, and divide it by that monomial, negative 4x to the 6, y squared. And now I'm going to go do that division. Remember, these are each division problems, so what that means is I'm going to divide those coefficients, but then when I deal with the variables, I'm going to subtract the exponents top minus bottom. So an 8 divided by a negative 4 is a negative 2, and then x to the 6 divided by x to the 6, when I subtract those exponents, 6 minus 6 gives me 0, and recall that anything at all to the 0 power is just a 1. So essentially this is like a negative 2 times 1, which is a negative 2, and basically that means I don't need to show that x to the 0 because it is just a 1. Now when I do y to the 3rd divided by y to the 2nd, and I subtract those exponents, top minus bottom, that will be 3 minus 2 will give me a 1, so I get y to the 1st, and I don't need to show the exponent of 1. Now, when I take a negative 12 divided by a negative 4, that's going to be a positive 3, and now when I divide those bases, x to the 8th divided by x to the 6th, I will subtract the exponents top minus bottom. 8 minus 6 will give me a 2, so I have an x squared. And then same thing here, 2 minus 2 will give me 0. So it's essentially a y to the 0, which is just a 1. And recall that I don't need to show that 1, so I can get that out of there. And then in the last term, negative 4 divided by negative 4 is a positive 1, and that's my coefficient. And an x to the 14th divided by an x to the 6th, I will subtract those exponents, top minus bottom. 14 minus 6 is 8, so I get an x to the 8th. And like we said before, I don't need to show that coefficient of 1. And then y to the 6th divided by y squared, I'm going to subtract those exponents. 6 minus 2 will give me a 4. And so now I just look and say, do I have any like terms at all? Well, this doesn't have any x's. This doesn't have any y's. This has both x's and y's. None of them are to the same power. So none of these are like terms, and this is as good as that one gets. All right, let's try a couple more just to make sure we're really, really good at this. And it's going to feel like I'm kind of wearing it out, but there is a point to doing this next one. Notice that I have a term sitting here. Here's the subtraction separating off and the name tag for the next term. Here's the addition separating the next term. There's the subtraction separating the last term. 4 terms, remember, means that it's a 4 polynomial. So I'll take my first term and I will divide it by my monomial that's in the denominator. I will take my next term and I will divide it by the monomial that's in the denominator. I'll take the third term and I'll divide it by the monomial that's in the denominator. And then I will take my last term and I'll divide it by that monomial that's in the denominator. So now I'm ready to do that division. Keeping in mind, division problem, that means divide the coefficients. The only time I'm going to subtract is when I divide bases. When the bases are the same, I subtract the exponents. But here, these are coefficients. I'm just going to do the division. So 25 divided by negative 5 is a negative 5. And now when I do x to the 8th divided by x to the 5th, I'm going to keep the base once again because it's all about the base, And I'm going to subtract 8 minus 5 will give me 3. Now in the next term, negative 50 divided by negative 5 is a positive 10. And when I do an x to the 7th divided by x to the 5th and I subtract those exponents, 7 minus 5 will give me 2, so I get an x squared. And then here, when I take a 3 and divide it by a negative 5, I'm going to get a nasty decimal. We've talked about this before, that I really don't want to deal with decimals. I'm just going to keep that fraction. I'm going to simplify the fraction if I can. 3 over 5 does not simplify, so I'm just going to call it a negative 3/5. And then x to the 6th divided by x to the 5th, 6 minus 5 will give me a 1, so I get an x to the first power. Now on the last one, negative 40 divided by negative 5 is a positive 8. And when I divide x to the 5th divided by x to the 5th, once again, subtract those exponents. 5 minus 5 is 0. Gives me an x to the 0. But recall that anything to the 0 power is a 1. And this is just an 8 times a 1. That's just an 8. So I don't need to show that 1 right there. And we've talked before about the idea that because these bases are the same, and it's an x to the 5th divided by an x to the 5th, entirely the same factor, the factors themselves can cancel out. Now recall, combine up like terms if you can. X to the 3rd, x to the 2nd, x to the 1st, no x at all. None of them are like terms. So I cannot combine any of them, and that is as good as that one gets. And so now in the last example, notice this one's set up entirely different than all the others. All the others had your polynomial up on that numerator, a monomial on the denominator, written vertically more or less. This is written horizontally. But this division symbol indicates you're going to take your binomial here, 2 terms, take that binomial 16y squared minus 8y, and you're going to divide it by that monomial of y. So now it goes back to what we were doing before. That indicates take that first term, 16y squared, divide it by y, take your minus 8y, divide it by y. Now 16y squared divided by y, I'm going to subtract those exponents because the bases are the same. 2 minus 1 is 1, and so that will give me a 16y. And then here, 8 divided by 8 is 1, and so I get a minus y. Oops, I really messed up. I can't believe I did that. It's a negative 8y divided by y. I kept thinking something's wrong here. Negative 8y divided by y. So now those y's will cancel. That's much better. Y divided by y, like I said, that would be a y to the 0. But y to the 0 means 1, so I don't need to show that. And basically those y's cancel and I get a negative 8. Now there's a y here, no y here, so that means I cannot put them together. They are not like terms, and that's as good as that one gets. Much better there. So I hope that helps with the idea of dividing a polynomial by a monomial. And again, all that you have to do is simply divide each and every term of the polynomial that's on that numerator by that monomial in the denominator, and then look and see if you can combine up any like terms. Likely you won't, because if you could, they would have been combined up in that numerator anyways. Hope it helps. Have a great day.